Hello, my name is Carsten, and in this video I'm going to explain what acceleration and deceleration is. I'm also going to explain how they are shown on velocity time graphs. Acceleration is defined as the rate of change of velocity and is measured in meters per second per second. Acceleration is a vector quantity because it is linked in with velocity, which is a vector quantity itself. When velocity changes, there will always be acceleration. Velocity is basically speed in a certain direction, which means that acceleration is the rate of change of speed in a certain direction. However, acceleration could also be the rate of change of only one component of velocity. For example, it might only be the rate of change of speed and not direction, or vice versa. The equation for acceleration is change in velocity divided by time. It can also be written as v minus u over t. U stands for initial velocity and v stands for final velocity. T stands for time. For example, if a football was kicked from a static position with a velocity of 0 meters per second and it reached a velocity of 30 meters per second in 4 seconds, to find the acceleration, you would first need to find the change in velocity. You would do 30 minus 0, which is 30 meters per second. Then you would calculate the change in velocity divided by the time. So you would do 30 divided by 4, which is 7.5 meters per second per second. Another example is in skiing. A skier's velocity changes from 7.5 meters per second to 10.2 meters per second in 3 seconds. To find its acceleration, you first need to find the change in velocity by doing final velocity minus initial velocity. 10.2 minus 7.5 is 2.7 meters per second. Then you would do change in velocity over time. 2.7 divided by 3 is 0.9. Therefore, the skier's acceleration is 0.9 meters per second per second. Deceleration is a reduction of acceleration, and it's also measured in meters per second per second. However, the value for deceleration is always going to be a negative number. It's also a vector quantity. The equation for deceleration is exactly the same as for acceleration. Change in velocity divided by time. For example, a cyclist may slow down from a velocity of 30 meters per second to 18 meters per second within 4 seconds. To find the change in velocity, we do the final velocity minus initial velocity. 18 minus 30 equals minus 12. Then what you do is minus 12 divided by 4, which equals minus 3 meters per second per second. So the cyclist decelerates at minus 3 meters per second per second. Deceleration is always a negative value. Objects can also decelerate. For example, in bowls, one bowl's velocity might change from 7 meters per second to 3 meters per second within 2.5 seconds. 3 minus 7 equals minus 4. Then you do minus 4 divided by 2.5 seconds, which is minus 1.6. So the bowl decelerated at minus 1.6 meters per second per second. In this example, the bowl decelerated because of the friction from the ground. Velocity time graphs can show acceleration and deceleration. As you can see, a straight horizontal line shows that there is no acceleration. This is because the velocity is not changing. An upwards curve shows increasing acceleration, and a positive straight line shows constant acceleration. However, a downwards curve shows a deceleration of an object or body, while a negative straight line, like the one on the bottom right, shows constant deceleration. Thank you for watching.